Right. So we will going to proceed to our next chapter in our subject about stress in a soil mass. So this one's just our second to the last topic in our subject, geotechnical engineering or soil mechanics. Again, guys, in this topic, we will going to review some fundamental principles in your um, mechanics and strength of materials and apply these principles to soils treated as elastic porous materials. So, lagi nyo rin tandaan guys that this chapter contains a catalog of a large number of equations for soil stresses. Right? So, ngayon, let me give you a brief introduction about your stresses in a soil mass. Okay? So, as described in weight-volume relationship, guys, and plasticity, soils are multi-phase system. So, in a given volume of soil, kung ito yung soil natin, the solid particles are distributed randomly with void spaces in between. So, the void spaces are continuous and are occupied by water, air, or both. So, ngayon, in real life situation, 'di ba? Kung minsan nagko-collapse yung building because hindi na kayang i-carry nung lupa. Okay? Na-stress na siya eh, 'di ba? Hindi lang tao na-stress. Ultimo yung lupa na yung soil natin na-stress, 'di ba? That's why some cause of failure ng building natin is cause of soil liquefaction. Yes? Try to read about your soil liquefaction. May magiging idea kayo dati doon. So, ang point ko dito, we will going to study this one in order for us to know na paano natin i-analyze later all yung soil sa actual site. Yes, paano ano kaya yung magiging ano yung stress at certain point kung saan natin ilalagay yung gusto natin malaman na stresses. Okay? So, in stress in a soil mass, ito yung ibig niya sabihin. So, stress at a point on a soil layer are caused by two. Dalawa. So number one, we have here your what we call your self-weight of the soil in layer, or that is what we call your geostatic stresses. Okay? Meron tayo tinatawag na geostatic stress or stresses. So mamaya, explain ko to mamaya, itong self-weight of the soil in a layer. Okay? So, malalaman nyo kung paano mamaya yan. And then, number two, we have here your added load. Ano nga ba itong added load? Example, these are your surcharges. Example lang, ito yung mga buildings, yes, buildings, roads, and etc. Okay? So, marami pa. Basta yung mga added load mo. Okay? So, ibig niyang sabihin, kung if this one would be your ground surface, guys, ito yung ground surface natin, paano ko malalaman si self-weight on the soil of the soil in layer? Okay. Like for example, meron kang point dito. And let's try to consider that point would be point JM. Okay? That point JM. Starting from this point, okay, from your ground surface down to your point JM. Okay? This one will experience stress. Ano yung stress mo dito? It is the self-weight, yung bigat ng lupa from this point pababa. Okay? That one would be your self-weight of the soil in a layer. Tama? And again, ito naman, if there is another load applied in above the ground surface, for example, meron kang building dito, yes? Meron kang building or your additional load here. Okay? This one, the load carried by your superstructure or your building will going to transmit or exert force down to your point GM. And wherein, your point GM will experience stress. Tama? So hanggang dito, pwede natin later on masolve yung stress ni point GM dito. From your additional load, your added load, or your surcharge caused by your superstructures, plus your self-weight of the soil in the soil layer. And from this point GM, madidetermine na natin ito. Right? So, this one, sulat ko lang, that this one would be your additional load or your added load such as buildings, roads, and etc. Okay? And then yung self-weight alone, siyempre later on, meron kang unit weight of your soil here. Tama? And at a certain height. And let's say your height there would be Z. Okay, that would be your definition of your stress. Yan yung mga na-experience ng um, stress ng mga points natin kung saan mo gustong i-determine yung mga stress niya. Okay, for example, kung gusto mo naman determine yung stress from this point, and let's say that this one would point A, made-determine mo lang yan. Okay, so ituturo ko din yan mamaya. Okay, now next, proceed tayo dun sa tatawag nating geostatic stress. Ano nga ba itong geostatic stress? Okay, what would be this geostatic stress? Actually, guys, ang geostatic stresses mo composed of 3 stresses. Okay? Number 1, we have here what we call your total stress, which is denoted as your sigma. And number 2, we have here your what we call your pore water pressure, which is denoted as U. And also number 3, we have here what we call your effective stress. Effective stress, okay, which is denoted as sigma prime. So our main concern here is later on would be determine the effective stress, wherein the meaning of your effective stress is simply the portion of the total stress which is actually carried by the soil grains themselves. Okay? So ibig niyang sabihin dun, ang effective stress natin, guys, ito yung is the stress resulting from particle to particle contact of soil. So ito yung mga main concern natin dito. So yan yung tatlong composition of your geostatic stresses. Right? So ngayon, from your geostatic stresses, guys, in total stress, pore water pressure, effective stress, dinevelop ngayon ni the father of geotechnical engineer, which is your Terzaghi. See? Carl von Terzaghi. So during 1936, Terzaghi developed the formula Terzaghi. The formula of your effective stress, which is effective stress is equal to total stress minus your pore water pressure. So ngayon, or mamaya, as we proceed, I will going to show you how this formula has been developed. Okay? Yung Terzaghi natin during 1936 yan. So, before we proceed to effective stress, okay, itong effective stress, which is our main concern in this topic about stress in a soil mass, proceed muna natin i-define kung ano ibig sabihin ni total stress. Okay? So, number 1, total stress. Again, total stress is denoted as sigma. Right? Yan si total stress. Ano nga ba ibig sabihin ni total stress sa atin? Your total stress or total vertical stress is considered is the stress due to all forces on the soil sample. Okay? Soil sample. Yan. So, ngayon, example lang. If this one would be your ground surface, okay? Ito yung ground surface natin. And if we will going to determine the total stress at this point A, okay? Sabihin natin that this one would be our soil element. Ito yung soil element natin. Sabihin natin ito siya. Okay? Ito yung soil element natin. Right? And at this soil element, we have a height from this point, or your soil element, which is a height of your Z. Okay? And then take note that through this soil element, if you will go to extend this one, kung ito lang yung consider natin, ang may experience ngayon ni soil element A mo, guys, is simply the self-weight above your soil element. Or meaning to say, yung weight galing from your ground surface pababa, yan yung magiging stress niya. It is simply the self-weight of your soil. And then from here, makikita mo na, or if you're going to review, your weight is simply equal to your unit weight times your volume. Tama? Unit weight times your volume. Wherein, kung ito yung ground surface natin, guys, siyempre, expect natin, and let's say, for example, that this soil material, ang unit weight ng soil sample natin is gamma. Okay? So, ang magiging weight mo dyan, weight mo is simply equal to gamma, tama? Times yung volume mo, it is the height from your ground surface up to your soil element A, point A, times Z, times yung area nito. Area ng soil element mo. Alright? Area ng soil element mo. Times your area. Okay? That would be the weight experience from this point. It is the gamma times volume. So ngayon, ano yung magiging stress natin dito? Take note. Your stress, guys, in your strength of materials, ang stress natin is simply equal to what? The force divided by area. Okay? Force divided by your area, or simply, it is the weight all over area. Bakit ko sinulat yung weight dito? Weight over area. Simply because, guys, itong ma-experience ng point na to, itong point na yan, it would be the weight of the soil above your soil element A divided by your area. Kasi yan yung definition ni stress natin. Nakuha? So, from here, mako-consider natin, your stress, total stress sigma, would be equal to weight. What is your weight? Your weight is simply equal to gamma times Z times your area of the soil element divided by area A. Tama? So, mangyari, maka-cancel ito. Cancel. Cancel. Kasi ito is weight all over area. Tama? So, stress mo ngayon, total stress mo would be equal to what? Gamma times Z. If you will going to consider the unit, your gamma is in terms of kilonewton per cubic meter, and your Z is in terms of meter, so that your stress is still in kilonewton per meter squared, or this one would be in terms of kilopascal. Again, your total stress from this point A is simply the unit weight of your soil solid times your Z, the height from the ground surface up to the point of your soil element. So, ito yung magiging total stress. So, simple lang, di ba? Gamma times Z. Parang wala pinagkaiba sa fluid mechanics or your hydraulics. Gamma H, that is your pressure. Okay? Yan. Yan yun. So, take note for this unit. So, again, your gamma here is in sorry, unit weight of soil. And then your Z there, it is the height of your soil element above from ground surface up to your point A. So, yan yung magiging height natin. Okay? So, that's it. That is the definition of your total stress. So, we are done. So, simple lang. Diba, kung gusto mong determine total stress dito, it would be what? Total stress would be equal to gamma times Z. Your gamma here is the unit weight of your soil. And then next, how about yung tatawag natin pore water pressure? Yan. Ang pore water pressure naman tayo mag-proceed, guys. So, pore water pressure. Wait lang. Pore water pressure. Number 2, pore water pressure. Okay? So, pore water pressure is denoted as your U. Okay. Review ulit natin, guys. What is the meaning of your pore? Pore is a void. What is water? Water. So, ibig niya sabihin, there is a water inside the void, it is occupied only by your water. Okay? So, kung if this one is your soil particle, kung ito yung magiging soil particle natin, guys, okay? Yan yung magiging soil particle natin. Yes? And then, this one is your pore, which is equal to your void. And there is a water inside it. So, meron tayo ng water occupying this void. And we will going to consider that this one is fully saturated simply because it is occupied by water only. Alright? So, ito naman, itong portion na to, ito yung grain material natin, yung particle natin. Grain material. Always take note, guys, that in analyzing your pore water pressure, yung tubig mo dito, expect the water exert force in hydrostatic condition. So, may force siya. So, parang gusto niyang from this point, okay? From this point, yan, i-exert niya. May mga exert force dyan. Yan, ito yung mga force mo. Ito yung mga pressure, di ba? Water exert force in hydrostatic condition. Right? So, from there, paano ko malalaman yan, sir? Paano ko malalaman yung pressure dito? Simple lang. So, ang mangyayari, we're going to place here a piezometer, okay, at a certain height, h. Okay? If you will going to determine the pore water pressure of this one, ang mangyayari dito is simply equal to pressure U would be equal to, we are talking about your water, ang unit weight na gagamit mo dito, hindi na unit weight ng soil. Kundi ang gagamitin natin would be unit weight of water, tama, times H. So, this one would be your pore water pressure. So, ngayon, sir, paano pag actual? Hindi naman tayo pwedeng gagamit ng piezometer or your standpipe. So, sa actual kasi ganito, di ba? If this one is your soil in actual, sulat ko dito. In actual. So, ito yung magiging soil element mo. Tama? For example, ito yung magiging soil element natin. And if it is fully occupied by water, siyempre, ang soil natin dito is saturated soil. Okay? And let's say, like, for example, yung shaded in blue, yan, shaded in blue, yan yung magiging tubig natin. Okay? Paano ko malalaman yung pore water pressure dito? Simple lang. Okay? So, paano? So, take note, ito yung magiging path nung tubig mo. Okay? This one would be your path of your o di kaya yung channel nung tubig mo. Okay, siyempre pag ganyan siya, right? Okay, pag ganyan. So, if this one would be your ground surface mo yan, and then siyempre water table na rin yan kasi fully saturated by water. Kahit ganito yung itsura ng flow path mo or your channel, and let's try to consider that this one would be your Z. Okay? And then the other one, kung ito naman, pag ganyan, okay, or di kaya pag ganyan, still, yung pore water pressure mo dito, guys, this one would be your height Z, which is equal to H. Again, yung height Z mo din dito sa portion na ito would be equal to H. And yung height mo din dito, yung Z mo dito, which is equal also to H. Again, ito yung flow path mo. Ito yung flow channel mo. Okay? Parang in-exaggerated ko lang yung magiging itsura. Still, guys, ang pagkukonsider dyan, if this one would be your groundwater surface and this one is your water table, simply because this is saturated soil, ang mangyayari, ang pore water pressure mo is still gamma of water times H. So, ang focus ni pore water pressure is yung tubig. Okay? Yes, that is still your pore water pressure. Right? So, ngayon, again, the definition of your pore water pressure is simply what? Ano yung definition ng pore water pressure natin? Pore water pressure natin is simply the stress induced by water pressures. So, this one is stress induced by water pressures. So, again, ang other term for water induced ay for other term for poor water pressure, ang ibang tawag sa kanya is also called as neutral stress. So, neutral stress. Right? So, neutral stress ang tawag kay poor water pressure. So, again, this one is your water exert in hydrostatic condition. Tama ba? So, ngayon, yung tubig dyan, syempre, gusto niyang, parang gusto niyang lumabas. So, ang mangyayari, you're going to exert force dyan. May pressure dito. Okay? So, ito yung mga exert force na exert pressure in hydrostatic condition. Tama? So, again, huwag niyong kalimutan yan. So, ino-introduce ko pa lang sa inyo yung parang concept niya. Pero mamaya, maglalagay tayo ng example. Let's say, meron tayong at certain point, we will go to determine the stresses, the pore water pressure, the total stress, and yung effective stress. Right? So, again, before we end up in this video, kasi almost 22 minutes na, introduce ko na lang sa next video yung tinatawag kong effective stress. Okay? The number 3 composition of your geostatic stress. Right? So, again, guys, lagi nyo rin pala tandaan dito, always take note, sa pore water pressure, note that, number 1, for soils above water pressure, or above water table, okay, ang water pressure mo is always equal to 0. Okay, for soils above water table, your pore water pressure is always equal to 0. And if fully saturated, number 2, if fully saturated, right? All the voids filled with air or water. Siyempre water. Okay? Filled with water. Okay, ibig niya sabihin, if this one is your ground surface, right? Ground surface mo yan. Andito yung water table mo. Yes? Above this water table, ang mangyayari, ang water pressure mo dito, pore water pressure mo 0. And below your water table, ang pore water pressure mo, syempre meron. Right? Tama? Okay. Now, so see you in our next video, guys, about yung sa effective stress. Thank you and God bless everyone.